Red, green, blue, ooh, ooh. Red, green, blue, ooh, ooh. Red, green, blue, ooh, 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 ooh.
Good morning, everyone. Welcome to my latest adventure where I build upon my last couple videos, and now I'm getting my RGB LED common anode module blinking all of the different colors that are available. And by that I mean all of the different color combinations. Allow me to go through the code explanation. At the top, import rpi.gpio as GPIO import time. I've covered this before. These are some of the libraries used to control the GPIO pins and to make use of a delay within the code. Here's the GPIO.setMode GPIO board line. That means we're using the board number system of the physical pins. And now I am setting up output pins on the RGB LED. Pin red LED equals 11, pin green LED equals 13, pin blue LED equals 15. And then I go through the steps: GPIO.setup, pin red LED GPIO.out, initial equals GPIO.high. Pins 11, 13, and 15 are configured as outputs for the RGB LED. Initial equals GPIO.high means the LED starts off because this is a common anode LED. It starts off high. For common anode, low turns the LED on. High turns it off. The next block of code is setting up a single input pin button, and as I will show in the video section that I took of my circuit, I am going to swap out a single push button for a 555 timer. Now, I was careful to run my 555 timer off of the 3.3 volt power out pin on the Raspberry Pi, because since I'm sending that signal into an input pin, anything greater than 3.3 volts could damage the Pi. So I was careful to have the 555 timer running off of 3.3 volts, so the output was equally low, and I think it ended up being 2.5 volts when I checked it on the multimeter. But I'm digressing. So this pin underscore button equals 29 is my code where I set up an input pin, and this could be connected to a push button, and it's normally low, and when it receives a high signal it will put a corresponding combination of outputs on the 3 output pins, according to the code. Pin 29 is configured as an input for a button. I'm making use of pull-ups and pull-downs. Actually, there's a pull-down resistor, and this ensures that the input pin is normally low. So it reads high only when the button is pressed. Next in the code, I'm defining the different LED colors, and colors equals true, false, false, which is red, false, true, false, which is green, etc. Each tuple represents the state of the RGB LED. True equals off, false equals on, because of common anode logic. This array is a color sequence that the button will cycle through. The next part of the code is a color index and start message. So color underscore index equals 0. Print, press the button to cycle LED colors. Control plus C to exit. Color index tracks which color in the list is currently active. The print statement is just user feedback. Next is the main loop, and it runs continuously, and it reads try, while true, check if button is pressed, if GPIO.input pin underscore button equals GPIO.high. The code runs in a while loop, constantly checking for button presses. GPIO.input pin underscore button equals GPIO.high detects when the button is pressed. Next, this code updates the LED. Red, green, blue equals colors, and in square brackets color underscore index, and then below GPIO.output pin red LED GPIO.low if red, else GPIO.high, and subsequently it shows the same type of code for the green LED and the pin blue LED. Overall, this block pulls the color from the colors list using color index, and it sets each LED channel. GPIO.low sends the LED on, GPIO.high sends the LED off. And overall, this handles the common anode logic automatically. Cycling through colors. Color underscore index plus equals 1 if color underscore index is greater than or equal to len colors color index equals 0. This moves the next color in the list. It wraps around to the first color if it reaches the end. Next is the debouncing the button part of the code, while GPIO.input pin button equals GPIO.high time.sleep 0.01 time.sleep 0.2 extra debounce delay. First loop waits for the user to release the button before continuing. Second delay adds extra time to prevent multiple detections from a single press. Then a small loop delay, time.sleep 0.01. Even when the button is not pressed, the program pauses for 0.01 seconds to reduce CPU usage. And then finally it finishes off with a graceful exit. Accept, keyboard interrupt, print, new line, exiting. If the user presses Ctrl and C, the program stops cleanly instead of crashing. The overall concept is that the Raspberry Pi constantly checks the button. Each press cycles the RGB LED through a list of colors. The code uses common anode logic: low equals on, high equals off. Button presses are debounced to avoid multiple triggers. The loop runs continuously until interrupted.
Red, green, blue, red, green, blue, red, green, blue.